GCSE, Year 10. Chemistry Paper, 1.
Good morning, everyone. Today we're going to learn about chromatography, a very useful technique for separating mixtures, especially colored ones. Let's start with a basic idea. First question: what is a mixture? A mixture is a combination of different substances that are not chemically bonded. For example, air is a mixture because different gases are mixed together, not bonded. So what is the main purpose of chromatography? Chromatography is used to separate mixtures of colored compounds, such as dyes in ink. Now, when we set up a chromatography experiment, we always draw a baseline. Why do we use a pencil to draw this line? Because pencil is insoluble in most solvents, so it won't dissolve and move up the paper like ink would. Now, next question. What do we call the liquid that moves up the paper? That liquid is called the solvent. And when placing the paper into the solvent, where must the baseline be? It must be above the solvent level. Otherwise, the ink would dissolve straight into the solvent. You'll also notice we place a lid on the container. Why is that important? The lid is used to stop the solvent from evaporating. As the solvent moves up the paper, the moving edge is called the solvent front. Different dyes then begin to separate. Why does this happen? Because different dyes move up the paper at different rates in the solvent. Now think about this. What happens if a dye is insoluble in the solvent? It will stay on the baseline and not move up the paper. At the end of the experiment, what do we call the final result? The finished paper is called a chromatogram. Each separate spot on a chromatogram represents a different dye. So if an ink produces 3 spots, what does that tell us? It tells us the ink contains 3 different dyes. And if there is only 1 spot, it suggests the ink is likely a pure substance or single dye. Now let's talk about RF values. If the solvent front moves 10 centimeters and a dye moves 8 centimeters, what is the RF value? RF equals distance moved by the spot divided by distance moved by the solvent. So the RF value is 0.8. How do we identify 2 dyes as being the same substance? If, on the same chromatogram, they move the same distance from the baseline, they may be the same dye? Let's compare inks now. If ink A shows 2 spots, how many dyes does it contain? It contains 2 dyes. If ink B shows only 1 spot, what does that suggest? It is likely a pure dye. Now imagine 1 spot in ink C stays on the baseline. What does that mean? That dye is insoluble in the solvent used. Which 2 inks share a common dye? If spots line up at the same height, the inks share a dye. In this case, ink A and ink C share a common dye. Ink C also contains the most dyes because it has the most spots. Now, what is chromatography most useful for separating? It is most useful for separating colored components in a mixture. Sometimes we use ethanol instead of water as the solvent. Why? Because some dyes dissolve better in ethanol than in water. Which factor does not affect how far a dye travels? The color of the dye does not matter. Why do we stop the experiment before the solvent front reaches the top? To prevent the dyes from running off the paper and mixing. And finally, why must the solvent front be clearly visible? Because it is needed to calculate RF values. Well done. Pause the video, read formulas carefully, and practice to build confidence.